And I will, at the end, I will count how many people ask questions. And I will not read the questions. I will not remember whether they were dumb questions. You can get a better grade by asking lots of really dumb questions. A better grade. You could answer them. And I'm not going to check whether your answers are right. You could take every one of the dumb questions and answer it wrong, and you'll get a better grade. So go for it. You'll confuse your classmates. So, no, I mean, in the end, the social dynamics are so, and people do tend to try to help each other. So why do people answer my dumb questions on the Scala mailing list or the BlackBerry mailing list? In the end, they do it because it's come to be this big social contract that if someone answers my questions, I feel kind of obligated to answer some of the younger or even more inexperienced people's questions, and that way the real experts don't have to do that. So usually the experts, they will look at, say, which question are they interested in answering, and if the question sounds kind of intricate or makes them look good when they answer it, they will spring into action. If you post a question and say, well, my homework is to interleave two lists in Scala, how do I do that? Chances are no one's going to give you the time of day on this particular group, but there may be. There may be another community of students where that's going to do you any good, and you can certainly ask questions on the Piazza group that we have. And so as long as you don't totally give the answer away, by all means, give tips. So with the Vietnamese students, it took them a long time to get to the point where they gave each other tips, but eventually it did work out. So hopefully here it'll be a little bit faster. Yes, I asked them, why is it so hard? It was just totally against their education. Their education was, you sit in class, someone tells you words, you don't understand a word of what they're saying, but you all dutifully write it down, and then you think about it later. And then I asked them, do you think about it later? No. So why were they in class? They've always been in class. It's always been like that. So it was very interesting, very different way of teaching. And so it took me a while to get them. They were very, very good, so make no mistake, they were excellent. But they just had an ineffective way of dealing with learning stuff. All right, labs. So short lectures, labs, review. No lab today because you don't have a laptop yet, and people with adding and stuff. You'll work with a buddy. I will probably assign the buddies. That's what I'm doing in the other class. That generally works better. You need to bring a laptop. Any old operating system that fits on a laptop will do. And so in each day, one of you will code and the other one will type up answers. You've undoubtedly heard about pair programming, where you only have one keyboard and two people talk about, and one person is kind of the driver and the other one is the coder. And people who do it say it's great. It forces you to first think and then code, and four eyes see more than two, and when there's a bug somewhere and one person is all right wrapped up, the other person can kind of see it. To me, it seemed a little hardcore, so I didn't want to do that. Partially because I feel so uncomfortable when I don't have a keyboard in front of me, and it doesn't feel natural. So I figured it's okay if both of you have a keyboard, but it really does make a lot of sense to have two people work on one thing, because you see things together that you would not see on your own. So my analogy is always, one of the things that I'm very, very bad at, except teaching, is home repairs. When something is broken in the house, it's never a pretty day. And so I have no patience with the stuff. And so when I do it by myself, I can never fix anything. But when I'm with my dad, who also has no patience with it and who's terrible at it, when the two of us work at it together, somehow it always works. Because I give up after 15 minutes, but he still has enough energy left to talk me out of giving up. And then after 20 minutes, he's totally demoralized, but I have a second wind of energy because it actually worked for a while. Something worked, and I'm hopeful again. And so the two of us together, because we have different intervals in where we give up, we can finish a project that neither of us would be able to finish on ourselves. And that's very, very common, and when you learn something. So we're going to be doing that. So that does mean you really have to kind of show up for every class meeting, because otherwise you're going to be letting down your buddy who's it's going to feel lonely. So the expectation is you do show up for every class. And so we switch the roles between coding and writing, so that, because probably most of you prefer coding over writing up the answers, and that way everyone gets to do a bit of each. So yeah, don't worry about the English. I don't care about English. I just care about the code and just need a little bit of commentary in bullet English. Just 160 characters per observation or something. So it's just, I want to see, are you getting stuck or are you following along? If the labs turn out to be too long, then sometimes I might say finish them out of class, or if they're not that interesting, then I'll tell you it's okay to not finish them. We'll just have to see how it goes. It very much depends on just coding skills that everyone has. Software. So I'm expecting there's going to be some mix of operating systems, some Windows, some Linux, some Mac OS, and that's just fine, as long as everyone uses the same shell, and the common shell is Bash. So if you use Windows, it's not all is lost. You just need to install Cygwin, which has Bash. And so all of the instructions that I give assume that you have Cygwin installed, or if you have Linux, then you already have Bash. And if you have a Mac OS, then you already have Bash. So in those cases, you don't have to do anything particular. But that way, I can give you uniform instructions no matter what the platform is. And as those of you who run Windows will notice, is that Windows, sadly, is not the best platform for learning about new programming languages. Windows is, I'm sure, a wonderful platform for running Word and what's that thing, Excel. And that's why people are paying Microsoft a lot of money, because it's a platform for business users. It is not the best platform for programmers. And there's no law that says that a good platform for business users needs to be a good platform for programmers. And so we'll be doing a lot of work with the shell, and the Windows, like that command thing there is atrocious. And Cygwin tries to paper over some of these differences, and it does an amazingly good job, but it's not perfect. There are little itty-bitty issues, but it's okay. One gets the hang of it pretty quickly. And just when you curse Cygwin, remember that it's not Cygwin that's at fault. Cygwin tries to make the best out of a bad situation. So, and you could certainly install like a VM. You could install a VM and run Linux in a VM. If you have the memory, that's probably preferable. And that way you just follow the Linux instructions. Unfortunately, Windows by itself consumes a fair amount of memory, so if you have less than 4 gig on your laptop, then you're probably going to have a hard time getting much muscle out of a VM. But if you have 4 gig, go for it. If you're running Windows and 4 gig, install a VM, put Linux on the VM, and just use that. That's easier than running Cygwin. But if you must run Cygwin, it's all documented. I've had a whole bunch of students doing exactly that last semester, and they all cursed it at the beginning, and then they got past it. So we're going to be using Emacs, and the reason is I was pondering that last semester. I said, "Gosh, Emacs is this ancient editor, and people have bad vibes about Emacs." And so I said, I'll let people use whatever the most powerful text editor is that they like to use. And all the students said, "Oh, I love this thing, Notepad++, for example." And so it's the greatest thing. And then every time that we needed to do some heavy lifting, Notepad++ not only couldn't cut it, but didn't even get to the point where the problem could begin to be addressed. And so someone said about Emacs is that Emacs is so much better than all the other text editors. It's like the sun that not just outshines the other stars, but makes them disappear. And that actually is true, oddly enough. So Emacs is this horrible program that's hard to use, and that's like, you can see it's 30 years old, and the user interface conventions have changed. But every time someone comes up with a relatively new programming language, the first thing that someone does is make Emacs support for it. And the Emacs support always works better than the IDE support for several years. So I do a lot of Scala programming now, and the embarrassing thing is there is a Scala plugin for Eclipse, there's a Scala plugin for NetBeans, there's a Scala plugin for IntelliJ. I try them all. And every time that I actually need to get some work done, I'm back in Emacs because it works. I want to use the other ones. Emacs is ugly, but and so when the same thing with Ruby. There's a bunch of people who use Ruby on a Macintosh with, gosh, what's that thing? Who's a Mac programmer? No Mac programmers? There's a whole bunch of people who love doing Ruby on the Mac, and they use this thing called TextMate. So I looked at TextMate and said, that's just like Notepad++. It doesn't even begin to do the kind of things that the really bad Emacs plugin does for Ruby. And so we're just going to do it. And that way I don't have to forever ask, can your editor do this? Because we're all going to be using the same old crafty editor. And it'll work. The trouble with Emacs is it has a learning curve of probably about a year. And after a year, one knows everything about it, and you can never escape again, because it's just so much more powerful than everything. But in the first few weeks, it's kind of painful. I know you might say, that's a long learning curve, a year. Well, for a career of 30 or 40 years, a year is nothing. So, live with it. Version control. We're going to be using the version control for a couple of things. One is for checking in homework, so that I can monitor continuous progress. And the other one is in the exams, so that I can monitor that. The exams are, I guess I didn't mention that, the exams are like open book, open notes, open laptop, open everything. And open internet. You can Google for the answers. And if you find them, I will have failed. Because, of course, I Googled for it first before I put up the questions. But there is always the incremental risk that people kind of communicate with each other, and I try to make sure that you don't. But how do I know? So what I now do, and it works great, is you have a version control system on your machine, and use check-in every 10 minutes. And it's very hard to cheat, and at the same time leave a credible trail where you check in. And once you've used the version control system, the checking in has become so automatic that it'll be fine during exam. So that worked wonderful. Reduced all temptation to communicate, because it just, if you have an exam where there's a check-in every 10 minutes and they're all empty, and just before the end, out of a sudden, all solutions have sprung to life, you know that something fishy must have happened. But if they incrementally get more convincing, then that's kind of so. And we're going to be using Mercurial, not because it's wonderful or because everyone uses, but because it's really easy. Mercurial has. Did anyone use Mercurial? Does anyone use Git? No one use Git? Okay, yeah. So several people use Git, right? And is Git better than Mercurial? I don't know. GitHub is good, but Git by itself, it has about the same features. It has, for advanced users, has some pros, has some cons. Mercurial is dead easy, and it has this huge advantage that you can run Mercurial on your own machine without having to install much at all. You install Mercurial and that's it. And then you can, it's just super trivial to install, and then you can clone your repository when you submit your homework or when you submit your exam. You'll see it. You'll like it. And finally, we're going to get started with Scala in the first couple of weeks. So my thinking was that you probably would like to have some warm-up with functional programming. And so Scala is this interesting language in that it's both functional and object-oriented, and it tries to do programming in the big and the small, and DSLs and all of that. But I figured we can use it as a refresher for functional. Later on, we're going to be looking at other aspects of Scala for concurrency, for DSLs. But we'll start with functional. And it's similar enough to Java that if your scheme and stuff is rusty, you're going to get the concepts in a language that's familiar to you. And we're going to be needing some of the things for the next language that we're going to get into, namely Ruby, where Scala and Ruby are going to actually look pretty similar, and it'll make it simpler to make that transition. So you need to install Scala. Here's some websites. Oh, advertisement. Yeah, might as well do these, and then before going to the prerequisite thing. A couple of advertisements, people who asked me to pitch something. So Ron Mack has this great course called History of Computing, so what happened is, he was going to teach this course, History of Computing. He's active in the Computer History Museum and stuff. And then he figured maybe he could have a guest lecturer or two who would talk about some important parts of computer history. And so he sent a bulk mail to like 20 people who he thought, one or two of them might actually say yes. Steve Wozniak, James Gosling, and a whole bunch of other luminaries. And almost every one of them said, yeah, sure. And so now he had a problem that he now has to deal with all of these speakers.